now we're going to get into it's kind of like an extension of circular motion. It's gravitation. Okay, it's a pretty quick topic. Like I said, I think when I went to the AP Institute, one of the guys broke down the sample test in terms of like percentages of questions that you may see, and in terms of multiple choice, and gravitation I think came out to about 2%. I'm sorry, 5%, which equates to about 2 multiple choice questions. Okay, so it's not a big major topic in terms of AP. When I was in college, I probably experienced gravitation in Physics 1, so my freshman year, my first semester freshman year. I don't really remember ever talking about it again. Okay, so it's not a massive, massive topic, but it has to do with circular motion. Okay, so let's say we've got two large objects. Two objects, it can be any object. Okay, they both exert a force on each other because of gravity, because of their mass. All right, and the thing that happens with gravitation is if you're going to experience this gravity, and it's going to create a gravity that's large enough for you to actually feel it, these objects have to be huge, right? They have to be planets. Okay. In the book, they talk about an example of if you put, I think it's just two spheres, you put them close together. What is the amount of what is the gravitational force between them, the attraction between them? And it came out to be like the weight of one hair. That's how much force is being attracted between them. So, you need to have massively large objects in order for them to cause some sort of attraction. That's why we have planets, right? In the moons and things like that. There's gravity between them, attraction between them, because they're so huge. All right. So we've got two objects, right? One of mass large m, one of mass small m. Okay? And they're a distance apart called r. Isaac Newton does a lot of observations and comes up with a relationship between two objects that explains their attraction to each other because of their masses. He finds that the force of gravity, the force of gravitation, is equal to this thing called capital G times the mass of one object times the mass of the other object divided by the square of the distance between them. Okay, that's a quick little thing to discern, is that r is typically the radius, but it's the distance between them. It's not like half of it. Okay?
So if that's true, if it takes massive objects to attract massive objects, how did everything start? If there's dust,
I wasn't around then. I can get into that, but I'm not going to get into it now because it'll destroy the class.
If you're talking about like planets and like let's say you have like the core of the sun and like the core of Earth, is R like the direct center, or is it like from the surface?
It's typically they say from center to center, but typically in a problem they'll just say the distance apart, and that's what you just use. So you're not going to say the distance from the Earth to the sun is this, and then add like the radius of the sun and the radius of the Earth to get that real distance. Just go with what they give you. Okay. So you can see that it's a function of these two forces. This G right here, this is called the gravitational constant. So what happened was he was doing these experiments and he saw that there was this relationship between these items right here, but there needed to be something that kind of put it all together. And it ended up being this thing, this gravitational constant. So G is very simply equal to 6.67 times 10 to the negative 11. Okay? And this will explain the gravitational force between any two objects. Okay? Typically, we say that big M is the larger of the two masses, right? And little m is the smaller of the two masses. All right? So if you think about, a person standing on the Earth, this large M is the Earth, the small m is the person standing on it. All right? Now, a pretty cool relationship that gives you, so if you were to say take this, and you plugged in the information for 6.67 times 10 negative 11, the mass of the Earth, which you can look up, it's in your book, your mass, right, and then the radius of the Earth, all right, so the distance from you from the to the center of the Earth, you would come out with 9.8 meters per second squared. Okay, which is pretty cool. So this is the force of gravity, but we also know that the force of gravity, known as our weight, is equal to the mass times gravity, correct? We know that? So if we're talking about the same force, so we can set them equal to each other. Okay? Where this little m and this m are equal to each other, they're the same thing. So this is the weight of the object, right? This is then the gravitational force that it experiences, this object right here. So we can cancel these out. And we get this general expression that if I want to know the gravity that any object, any body generates, it's just g times the mass of the object divided by the distance, the radius of it. So you can use this and find the gravity that any planet will generate, or it creates. Okay? Now this gravitational force, this g m over r squared, or m1, m2 over r squared, it's another centripetal force. That is the force, that's a gravitational force that keeps planets in that circular orbit. Right? We say that they're ellipses. One of Kepler's laws says that they follow ellipses. I believe 5 out of the 9 planets, they travel in ellipses, but they're extremely, extremely, extremely small, the ellipses, that we can essentially call them circular. Okay? But there is that gravitational force that pulls them in. And that is the force that it doesn't cause them to speed up or slow down, it just causes them to take that circular or elliptical orbit. Okay. John?
So gravitational force, in this case, is centripetal force, and keeps them in orbit. What keeps a lot of planets spinning?
Spinning, I believe, and this is outside of what we've been talking about, I believe it is, from what I've read, it's the motion of like the core of that planet. Okay.